All right, I thought I'd chime in here on Saturday morning and make a little video on homework 8, part 3, just to sort of give you a frame of reference or a video to watch on how to set these problems up. Because, again, they're the same to me every time, but each one has got its own unique set of circumstances. And um, so, yeah, here is problem 4 from that worksheet. Got a 6-foot tall man walking towards a streetlight. Oh, I forgot something in there. He's walking at 3 feet per second. That's important. And they're asking at what rate is the length of his shadow changing and how fast is the tip of the shadow moving. Okay. So one, following this algorithm, we put in the street light, which is 18 feet high, and somewhere out here is a 6-foot tall man, and there's the earth, and when the shadow comes off the pole, when the light comes off the pole, the shadow runs like that. Okay, so there's our picture. This is a right angle. It's pretty clear. Now we got to put in our variables. So let's do this. Let's call the length from the pole. So x is going to be the length of pole to man. And we're going to call this y here. And y is going to be y is the length of a shadow. And since part B asks to find out how fast this tip is moving here, we also want to call this whole thing some variable. I'm going to call that L. So L is pole to tip of shadow. And we've put the 6, we put the 18 in. What's the 3 feet per second? 3 feet per second is the speed at which the man is walking. So that's dx dt. And it's minus 3 feet per second because he's walking in the negative direction. All right, that's the setup. Part 2. Now using the defined variables, and you may have used different letters, A, B, and C or whatever, but I like X, Y, and L works as well. So part A says, at what rate is the length of his shadow changing? So that's dy dt. Because if you think about staring at your shadow, of course, it looks like this from your point of view. So y is the length of the shadow, and it's changing at dy dt. And then B, how fast is the tip moving? That's dl dt. Okay, and now with this setup, we can write down an equation relating them. So using similar triangles, the big triangle is 18 to L, so the sides, and the little triangle is 6 over y. Okay. All right. The only problem with this is that, well, we don't have x in there, do we? And we need to use dx dt in the problem. So let's change this, because if you just take this and differentiate it, all you have is dl dt and dy dt, and those are the things you're trying to solve for, and you can't solve for them. So let's replace L with what? X plus y. That's an if and only if, right? So that's a key step there, depending on how you set this up. I set it up different every time, but this L turns out to be X plus y, and that allows us to bring this dx dt in after we differentiate. So using this equation for 4, differentiate with respect to t, and then 5 input knowns and solve. So that's the hints I'm going to give for this problem. I think from there you can do the rest. And now for problem 5. So here's what a cone looks like. We all know that. But you can't have a coffee cup that looks like that. So a truncated cone looks like this. Right? We just cut the bottom out of this thing, and this thing makes the coffee cup. Now this is key. Do not search Google for the equation of the volume of truncated cone. It's not going to help you because it's got too many variables. What you want to use volume is what? 1/3 pi r squared h, and then be clever. Okay? Alright, and if I give you any more, I've just done the problem for you, and that's not the point. But I remember this from the past. As soon as I assigned it, that people just looked up the equation of the volume of truncated cone. It's a mess. It's got 2 different radii and 2 different heights, and you can't use it for this class. It doesn't work with the technique that we're using. But this does work. And if you think about it for a few seconds or a minute or so, it should come to you. Otherwise, ask me and I'll give you more hints. Hope this helps.